So Ramba Mishen Sam Shosho to the pouch wherever. Alright, so we'll be looking at sequences and series, right? So basically our focus will be question 1, this and that. This is 1A, 2A and 2B. Okay, so we are just going to be going direct. I'll be explaining. Now, you have two things that we're looking at. We're looking at sequences and what? Series. In simple definition in Makamip, a sequence is just a function whose domain is a set of integers, positive integers. Okay? And the range is complex numbers. So what it is there's a function. The function can be un, an, and so on and so forth. As you will see up, there is un, so that is a sequence. Okay? So simply, a sequence is a function where you'll be getting from a set of real numbers, starting from positive 1 all the way to infinity. You replace in this function, and what you get is a set of another complex numbers, a set of complex numbers. So that is a complex sequence. So there is an object and an image. The object is positive integers. The image is complex numbers. That is a complex sequence. Now, since integers, positive integers that we're talking about are running from 1 to infinity, to determine if a sequence converges or diverges, we should find the image at infinity. If we can find the image at infinity, then we say that sequence converges. If we can't find the image at infinity, we say the sequence diverges. So for sequences, what you just be doing to determine if they converge or diverge is you will be finding the limit of that sequence, un or an, as we are approaching infinity. Okay? If this limit does not exist, it means the sequence diverges. If it is undefined, the sequence is what? If it's undefined, divergence. If we can find a number at infinity for that sequence, then we say the sequence converges. Hence with the question number 1A. Okay? 1A, determine the convergence of un. We know that un is a sequence. Okay? A series will have a summation of that. When you see summation of that, a series is a sum of the sequences. When z is 1, when z is 2, when z is 3, when n is 1, when n is 2, all the way to infinity. Some images. When we start summing all those images, what we get is a series. So to simply define a series in general, a series is the sum of the images of a sequence. The sum of all the images of a sequence. A sequence is a function whose domain is a set of integers, positive integers, and image or range is a set of complex numbers. Okay? Then now a series is just the sum of the domain of the image, not the domain, the image. So the differences that you notice is that series will have summation in front of it, then summation of that. We're talking about a series. A sequence will just be a function like this one. Un is equals to that. Are we following? Are we following? Are we following?
Yeah.
Okay. Kacha pero lero tuamba. Yeah, so simply to find to determine whether a sequence converges or diverges, what do we do?
Use the ratio test.
To determine what? To determine whether a sequence converges or diverges, what do we do? How we? My questions. When does a sequence converges? A sequence converges if we can find the limit at infinity. Sequences are different from series. We understand sequences, and we've explained sequences. So for sequences is just finding the limit at infinity. So if you ask when does a sequence converge, a sequence converges if the limit at infinity exists and you get the full marks. Sequence different from series. Sequence, there's one approach, that is finding the limit at infinity. For series, now it depends with the type of series that you're doing. If you have different types of series, you have Telescopian, you have geometric series, all those series that you use the tests that maybe geometric tests, ratio tests, and all those. Those are for series. Are we together? Are we together?
Yes.
All right. So, yeah. Anyway, even for sequences, we can also use the geometric test, the ratio test. You can use the ratio test to find the convergence of the series, because the ratio test also finds the limit as you are approaching infinity, even the root test. Down we come. So determine the convergence of this one, of the series. But if you use the ratio test to determine, if you use the ratio test or the root test to determine if a sequence converges, then what you are looking at is called conditional convergence. Because you are looking at the absolute value of that sequence. If you use the ratio test or the root test to determine if a sequence converges or diverges, what you're finding is the conditional convergence of that sequence. But just to find the convergence of that sequence, you just take the limit as n approaches infinity. Any questions before we start?
No questions.
Okay. So now, there will be cases where you'll be taught to determine the conditional convergence, whether it converges conditionally or and so on and so forth. Right? So when you use the ratio test, it may be found that the series itself the sequence itself, the sequence itself diverges when you take the limit as n approaches infinity. It diverges, but when you use the ratio test, converge. That's why it's called conditional convergence. Or it can be found that, basically that's it. Where this one diverges, these are questions, when does a series conditionally converges, or what is conditional convergence? Okay, conditional convergence is when the sequence itself diverges but converges with other tests. And we will understand as we are going further. So we are doing this question. So let's find, okay, so the question reads, determine the convergence of un is equals to that. So we are finding the limit as n approaches infinity of 1 plus I to the power n all over n. Does this converge or diverge? Do we remember our limits in second year? How do we compute this limit? Okay. Now, looking at this, determine the convergence. When you apply the limit directly into this, you're going to have a situation where you're going to have, when this number is raised to infinity, it will control it, it will approach infinity. Even n will approach infinity. So infinity over infinity diverges. Okay? Don't forget, diverges. But when you take the absolute value of the limit, okay? When you take the absolute value of the limit, so this one diverges. The sequence diverges when you plug in the limit directly. So diverges. But when you take the absolute value of the limit as n approaches infinity of the absolute value of 1 plus I to the n over absolute value of n. The top part will just be what is so limit as n approaches infinity. What will be the root this? The absolute value of 1 plus I infinity. Root of 2 to the power n over modulus of n. Okay, but still this also diverges because we still have infinity over infinity. But it could be found that when you take the absolute value, maybe if we had the 1 there on top, the 1 there and something there, it would do converge because we would have a real number 0. So, but this still is approaching infinity over infinity, which diverges. Okay, so in simple terms, this sequence does what? Diverges. Diverges. You don't freak out? So that is how you're supposed to solve the first one.